example number 2, integration with trigonometric substitutions. That's a big mouthful. All right, so it says t is equal to tangent theta. So t is equal to tan x. And then we need to start our triangle. Help us find a bunch of stuff out. So if this is x, that's our angle, x, then t, tangent is opposite, which is t, divide 1. There's just a 1 down there, so that's a 1. So then we have this as t squared plus 1. Okay, so now we have dt is equal to secant squared x dx. Okay, so we're going to take out a dx. We're going to take our dx out, and we're going to put in dt divide secant squared x. I'm not putting secant squared x in there because it has an x in it. I need everything in terms of t. Okay, so we need to find out what secant squared x is. Well, cosine x, actually I'll put this up here. Cosine x is equal to 1 divide t squared plus 1, adjacent divide hypotenuse. That means secant x is equal to the reciprocal of this, t squared plus 1, square root t squared plus 1. Secant squared is equal to just t squared plus 1. Okay, that's going to be helpful. Now we can do some substitutions. Okay, well, I'll do this one red, more space, different color. Okay, integral. 2 tan x, tan is t, so 2t over dx. What's dx? dx. Here, dx is dt divide secant squared. So that's dt divide secant squared, which is t squared plus 1. Cosine 2x. We haven't done that one yet. Cosine 2x. Well, cosine 2x is a double angle. We've got 3 options for that. I'm going to do cosine squared x minus sine squared x. So cosine squared x. Oh, this is getting really nasty. I'm going to start over here. Okay, 2t. Sorry. 2t over cosine squared x, which is here. 1 over, and I'm squaring it all in one step, t squared plus 1, minus sine squared x. Sine is t over this, so that's, I'm going to square it, t squared over t squared plus 1, times dt over secant squared, t squared plus 1. Now this is nasty. That's a lot of ugly looking integral there. All right, 2t. Look, denominator's the same. Denominator's the same. That's why I used this one. So I have 1 minus t squared over t squared plus 1 times dt over t squared plus 1. Things are canceling. We have integral of 2t over 1 minus t squared dt. Now here's an integral we can take. Okay, now going back to what you should have learned a couple weeks ago, the power of this is 1. So when I bring that up and I add 1 to it, I'm going to get a 0. Therefore, it's very similar to, it's a tip-off that this is an ln. Plus, I see the derivative on the top, almost. So ln, absolute value, 1 minus t squared. If I take the derivative of this, I'm going to get a minus 2t. So I need to put a minus out in front, plus c. Now what's t again? 1 minus tangent squared x plus c. That's your answer, ladies and gentlemen. Oops.